Table 310.16 in the National Electrical Code provides the required ampacity ratings for service subfeed conductors. For a service subfeed with an ampacity of 600 amps, column C is referenced. Based on the NEC 2020, Table 310.16 for column C and a 75 degrees Celsius, which is 167 degrees Fahrenheit conductor temperature rating, typical for THWN or XHHW conductors, the required wire size for a 600 amp service subfeed is 400 kc mil copper. It is important to understand how to properly size conductors for electrical services. This involves consulting the National Electrical Code, specifically Table 310.16, and taking into account the ampacity, temperature rating, and type of conductor. Firstly, determine the ampacity of the service. In this case, it is 600 amps. Secondly, refer to Table 310.16 in the NEC. This table provides ampacity values for different conductor sizes and insulation types at various temperature ratings. The table is organized into columns, and the appropriate column must be selected based on the conditions of use. Thirdly, identify the correct column. For a service subfeed with an ampacity of 600 amps, column C is referenced. Column C typically corresponds to conductors installed in a raceway or cable, and the ampacity values listed are based on specific temperature ratings. Fourthly, consider the conductive temperature rating. The temperature rating of a conductor indicates the maximum temperature at which it can operate safely. Common temperature ratings are 60 degrees Celsius, 75 degrees Celsius, and 90 degrees Celsius. For THWN or XHHW conductors, a temperature rating of 75 degrees Celsius is typical. This means that the conductor can operate at temperatures up to 75 degrees Celsius without degrading its insulation. Fifthly, find the appropriate wire size. Using Table 310.16, locate the route that corresponds to the selected temperature rating, such as 75 degrees Celsius, and find the column that corresponds to the identified column, column C. Read the ampacity value listed in that cell. The conductor size must be chosen such that its ampacity is equal to or greater than the ampacity of the service. In this case, the required wire size for a 600 amp service subfeed is 400 kc mil copper. Sixthly, understand kc mil. Kc mil stands for 1000 circular mils. It is a unit of measurement used to specify the cross-sectional area of a conductor. 1 circular mil is the area of a circle with a diameter of 1 mil, which is 1/1000th of an inch. kc mil is commonly used for larger conductors, such as those used in service entrances and feeders. Seventhly, consider conductor types. THWN and XHHW are common types of conductors used in electrical wiring. THWN stands for thermoplastic high water resistant nylon coated. It is a general-purpose wiring material suitable for dry and wet locations. XHHW stands for cross-linked polyethylene high heat-resistant water-resistant. It is a high-temperature rated conductor suitable for dry and damp locations. Eighthly, remember local codes. Local code requirements may vary from the NEC. It is important to always consult with your local electrical inspector to ensure compliance with local codes and regulations. Local codes may have additional requirements for conductor sizing, installation methods, and grounding. Ninthly, be aware of voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for feeders and 5% for branch circuits. Tenthly, understand derating factors. Derating factors are used to reduce the ampacity of a conductor when it is installed in certain conditions, such as when multiple conductors are bundled together or when the ambient temperature is high. The NEC provides tables and guidelines for applying derating factors. 11thly, consider parallel conductors. In some cases, it may be necessary to use parallel conductors to achieve the required ampacity. Parallel conductors are two or more conductors connected together to form a single circuit. The NEC allows the use of parallel conductors under certain conditions. 12thly, check for overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect conductors from overloads and short circuits. The size of the overcurrent protection device must be coordinated with the ampacity of the conductor. 13thly, ground the system properly. Grounding is the process of connecting electrical equipment and systems to the earth. Grounding helps to protect against electric shock and to provide a path for fault current to flow. The NEC specifies requirements for grounding electrical systems. 14thly, understand the importance of proper installation. Proper installation is critical to ensuring the safety and reliability of electrical systems. Conductors must be installed in accordance with the NEC and local codes. 15thly, consider future expansion. When sizing conductors, it is important to consider future expansion. The conductor should be sized to accommodate any anticipated increases in load. 16thly, ensure proper labeling. All electrical panels and equipment should be properly labeled to identify the circuits and conductors. Labeling helps to prevent confusion and errors. 17thly, use appropriate tools and equipment. When working with electrical conductors, it is important to use appropriate tools and equipment. This includes tools for cutting, stripping, and terminating conductors. 18thly, wear personal protective equipment. When working with electricity, it is important to wear personal protective equipment such as safety glasses, gloves, and insulated footwear. 19thly, follow safety procedures. Always follow safety procedures when working with electricity. This includes energizing circuits before working on them and using lockout-tagout procedures. 20thly, be aware of arc flash hazards. Arc flash is a dangerous phenomenon that can occur when electrical equipment is energized. Arc flash can cause severe burns, injuries, and even death. It is important to be aware of arc flash hazards and to take appropriate precautions. 21st, understand the importance of regular maintenance. Regular maintenance is essential to ensuring the safety and reliability of electrical systems. Maintenance should include inspecting conductors for damage, tightening connections, and testing overcurrent protection devices. 22nd, consult with qualified professionals. If you are not qualified to work on electrical systems, it is important to consult with qualified professionals. Qualified electricians have the training and experience necessary to perform electrical work safely and correctly. Remember that electrical codes and regulations are constantly evolving. It is important to stay up to date on the latest changes and to consult with qualified professionals when necessary.